Have you ever observed that it takes more heat to boil more quantity of water? So if you have a large pot of water, you would need more heat for the water to boil and less heat to boil a smaller pot of water. Have you also observed that different objects absorb and lose heat at different rates? For example, a pot of oil requires less heat to get to the same temperature as a pot of water. Now observe that the hotter you want your pot of water or oil to be, the more heat you will need to add. We can explain these three cases using the concept of specific heat capacity. The first case tells us that the heat, denoted by capital letter Q, required to raise a substance through a particular temperature is directly proportional to the mass m of the substance. The second case tells us that the heat required to raise the temperature of a substance varies depending on the material the substance is made up of. And the third case tells us that the hotter you want your water or oil to be, the more heat is needed to get it to that temperature. We can combine these three equations to get Q is directly proportional to m delta theta. If we call the constant of proportionality small letter c, we have Q equals to c m delta theta, which can be rewritten as Q equals mc delta theta, where m is the mass of the body, delta theta is the change in the temperature, and c is known as the specific heat capacity of the body. This is a constant that depends on the substance the body is made up of. The specific heat capacity of a substance is the amount of heat energy needed to raise the temperature of 1 unit of mass of the substance in order to cause an increase of 1 unit in its temperature. It is usually measured in joules per kilogram per Kelvin or joule per gram per Kelvin. For example, the specific heat capacity of water is 4,200 joules per kilogram per Kelvin, while that of aluminium is 900 joules per kilogram per Kelvin. This means it takes 4,200 joules of heat energy to raise 1 kilogram of water through 1 Kelvin increase in temperature, while 1 kilogram of aluminium requires 900 joules of heat energy to go through 1 Kelvin rise in temperature. Specific heat capacity is related to another quantity called heat capacity. The heat capacity of a body is the quantity of heat required to raise the temperature of the body by 1 Kelvin. It is also known as thermal capacity and is measured in joules per Kelvin. Note that the specific heat capacity does not depend on the mass of the body, but on the material the body is made up of, while the heat capacity depends on the mass of the body. So for example, the heat capacity of 2 different blocks of ice weighing 3 and 7 kilograms respectively are different, but their specific heat capacities will be the same. The heat capacity of a body is given by the formula uppercase C equals m multiplied by the lowercase c, where the uppercase c is heat capacity, m is the mass, and lowercase c is the specific heat capacity. This means the quantity of heat Q required to raise a body of mass m through a change in temperature delta theta given by Q equals mc delta theta can be written as the product of the heat capacity written as the uppercase C and the change in temperature delta theta. There's more on heat capacity to come, so keep learning.